Hello and welcome back to Nunley Math. I'm your host, Aaron Nunley. Thank you so much for joining us here again as we continue our discussion of absolute value problems. Now you will notice that you have an absolute value problem here that is similar to the kind you saw in the last video with the exception of a couple things. Notice this is the first time that we've had a variable on both sides of our equal sign, and also notice that in this particular problem we have absolute value bars on both sides of our equation. This really doesn't change a whole lot for us, with the exception of one big thing that we're going to talk about in just a minute. Just like in our other equations that we learned about in our previous video, if you have not watched that, you're probably going to want to go back and take a look at that one. Just like in our previous video, we're still going to split this into two separate equations. We're going to split this so that we have what's on the left equal to what's on the right with no absolute value bars, and then another equation where you have what's on the left equal to the opposite of what is on the right hand side of the bars. In the previous video we talk about the reason for that and the purpose for that. I'm not going to take the time to go back and do that here again today, but just suffice it to say that if you're unsure, go back and watch that one. It will all be very clear to you. Once you have split your equation into two separate equations, you're going to solve each of those equations just like you always have. That means for the equation over here on the left in blue, we're going to work to get both our variables on the same side. And we're going to do the same thing over here in red. Notice that this is a positive or plus 3. The way we undo addition is with subtraction. And over here, same thing. It's positive. We're going to use subtraction. Notice that because this x is positive, 1 minus 3 is negative 2, and 1 minus 3 is negative 4. Notice that we still have this negative 2 times and this negative 4 times. The way we're going to get rid of multiplication is using division with our property of equality. And you end up with x equals 2 or x equals 1. Notice I can switch those. That's a symmetric property. If two things are equal, they're equal. It doesn't matter which side they're on. And your solution is 2 or 1. Now, what I'm going to remind you of is we don't choose 2 or 1. What we're saying is if we're asked about every value of x that works, we're saying 2 would work or 1 would work. So even though we're using the word or, we still have to give both. Now, as always, when we're solving equations, we do want to do a check. Over here, when I do my check, you will notice that I rewrote the original problem, plugged in the appropriate value. In this case, we said 2, and then I simplify to see if the sides match. If the sides match, I give myself a check mark. If the sides don't match, then I know this value does not work, and I've either done something wrong or it's just a value that doesn't work. Since this has two solutions, we do have to check them both. So once again, I rewrite the original problem, substitute in the value I said should work, and simplify. In this case, you will notice that both the solutions that we found would work. The big difference between what we're doing here in this slideshow and what we did in the previous video is because we have a variable on both sides, we always have to check whether these work. Because in most equations, when we solve something correctly, we get answers that do indeed make the equation true. However, when you're working with absolute values, you have to be very, very careful, because even if you do every single thing right, sometimes you will get an answer called an extraneous solution. Extraneous solution. Those are solutions that even though we did everything right, and even though they appear to be correct, when we check them, for some reason, they don't work. Solving absolute value equations is one of the ways that extraneous solutions are created. Another place this tends to come up is when you're working with square root equations. We'll deal with that later on in the year. But for now, just know that even though prior to today, it was often in my class optional to check your solutions, if you have absolute value bars and you have x's on both sides, you must check them, because even if you do everything right, it is possible that one of these answers will not work and will be extraneous. So here's another equation, very similar to the last one. Notice again, we have absolute value bars on both sides, and we also have variables on both sides. What I'd recommend you do is pause the video, try this on your own. Once you have your solutions, restart the video and see how I did it. See if our solutions match. It's possible you had a little error. It's also possible that I made a little error, but I have the benefit of being able to edit, so hopefully I won't have one. And then, if we have the same answer, I'd recommend that you pause the video a second time and that you do the same thing with the checks. You work it out, then you watch me work it out. Certainly, if you think you're right as you work this out, you can skim ahead in the video straight to my answer and compare that way, and that might speed things along for you just a little bit. Anyway, I'm going to assume you've done that. Just like before, we are going to split this into two separate equations. Notice that the one on the left is exactly as written. I just changed these absolute value bars to parentheses. On the right, I did the exact same thing, except I stuck a negative sign in front of this 2. I'm going to work through this pretty quickly. Distributive property, property of equality, property of equality, little property of equality. And you end up with x is -6 or 4/5. Again, if that did not make sense to you, you're going to go back and watch it again. I did do that very quickly. Hopefully the solving of these equations is not overly difficult for you once we've done the split. If it is, you're going to want to go back and watch some equation solving videos from earlier in our series. I'm going to do the check. I plug in the -6, simplify both sides, and they do indeed match. Plug in the 4/5, simplify both sides, and they do indeed match. So both our solutions work here. Remember, what's going to happen is in a lot of these they will all work, and in some of them they will not, but it makes it important that you check every single time. I have one last one I want you guys to try. Again, I would recommend pausing the video and doing this on your own, and then restarting the video after you solve this, and then again after you do each check. What's tricky about this one is that when you split it, you need to remember that you have to make the entire side negative. That means this is a negative, and we need to put everything in parentheses. In the last problem, I didn't have to do that because there was already the absolute value bars in to group it. Since there are no grouping symbols here, I need to do that. Now, I am going to solve the equations fairly quickly. Notice I did some distributive property. Now I'm doing property of equality on both sides. Property of equality to move my my numbers or my constants. Little symmetric property to switch that x and -17 around. Property of equality on the 3. And you end up with these two solutions. Let's check those. We rewrite, substitute with the -17, and simplify. Notice what happens. In this case, we get 12 equals -12. That is not true. -17 does not work. Let's try it with the -9. Substitute, simplify, the -9 does work. Notice, even though when we work this out, there are two possible solutions, one of those doesn't work. And if you look closely, you can see right here what the problem is. When we use these solutions, occasionally we get the positive version being equal to the negative version. In this case, positive 12 equals -12. That happens because you've got the absolute value bars over here, but we didn't happen to have them over here. That creates those difficulties so that over here we don't catch it, but over here we do. Again, the big lesson for today, make sure you check every single one of these, even if you're confident you did it right, because you might have an extraneous solution. As always, thank you so much for taking the time to be with us. Make sure you smash that like button, make sure you ring that bell to turn on your notifications, and please, please, please leave us a comment in the comment section so that we know that you're watching. If you have suggestions for things we might do in the future, please let us know. We'd love to hear from you, all right? Thank you so much. You guys take care of yourselves. Bye-bye.